Welcome back to Mr. DuPage's classroom. This lesson is for my CP Algebra 1 class. It is 2.7 Day 1 Independent Events. It is the next step in our probability lessons we have been working on. First thing, make sure that the date is up in the top right-hand corner. And let's get right to work. So suppose you draw a card at random from the above collection. How many elements are in your sample space? Well, if you remember from our probability lesson, the sample space is the total number of things that can happen, or in this case, the total number of cards. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 10 cards in my sample space. Let's take a look at question number 1. You draw an R card and replace it. What is the probability that the next card you draw will be an R card? Well, in order to figure out this probability, I need to know how many R cards I have. Well, I have 1, 2. Remember that the probability of something happening is the number of times what we're looking for will happen over the total number of possibilities. So the number of times it will happen is 2 over the total number is 10. So 2 over 10 can be reduced to 1 over 5. Now, it said that we can replace this card. So after I have drawn it, I'm going to put it back in the deck. And so the probability that the second card will also be an R card is going to be exactly the same, since the 2 R cards are back in, and we still have 10 cards total. So it'd be 2 over 10 is equal to 1 over 5. My probability would be 1 over 5 for both those events happening. Now, question number 2. You draw an R card and do not replace it. Notice it says do not replace it. What is the probability that the next card you draw will be an R card? Well, for the first card that we draw, it's going to be the same as whether we're replacing it or not. So there are 2 possible R cards. There are 10 total cards, so it'll be 2 over 10, which is 1 over 5. For the second card, as soon as I drew the R card, I looked at it, I wrote it down, the fact that I'd drawn an R card, I'm going to chuck it out the window or throw it away or just move it to the side, however you want to think about that. So this R card is now gone. How many R cards do I have left? Well, I have 1. How many total cards do I have left? Well, I had 10 to start with. I got rid of 1, so I'm going to have 9 total cards. So the probability that my first card would be an R card is still 1 over 5, but my probability that my second card would be an R card after I do not replace it is 1 over 9. So now let's complete the table. We're still using these cards that are at the top of the sheet, the kind of cards that sort of spell the word random. Okay, now let's complete the tables. The probability with replacement. We have with replacement. So after I pull the first card, I'm going to put that back in the deck. So the first card is the probability of an R. So again, we just went over that. It would be 2 over 10, which is 1 over 5. The probability the second card would be an R. Well, since I replaced it again, it would be 2 over 10, or 1 over 5. Probability of an A card. How many A cards are up there? Well, I only have 1. So the probability that my first card would be an A card is 1 over 10. That would not reduce to anything. What is the probability that my second card would be an N card? Well, looking up here, how many N cards do I have? I have 1, 2, 3. So it would be 3 over, since I replaced that A, I still have 10 possible cards. All right, the next row, it says the probability of an N card. We just found out the probability of an N card is 3 over 10. Since I am replacing it, the probability of another N card would still be 3 over 10. There are 3 possible N cards. There are 10 possible cards. The next thing, it says the probability of a D card. How many D cards are up there? There's only 1 D card up there, and there's 10 total cards. Since I replaced the D card, I'm still going to have 10 total cards. How many cards are O cards? Well, again, that is 1 out of 10. Finally, the probability of an R card. Again, we figured that out a couple different times. So 2 over 10 is equal to 1 over 5. And the probability of an M card. Since I replaced the R card, there are still 10 possible cards I can draw from. There are 2 M's, so it would be 2 over 10 or 1 over 5. Now that's the easier one because we're putting the cards back in. Really, nothing ever changes. You still always have 10 possible cards, and it's just the number of cards that have the letter you're looking for. The next thing we're going to look at is without replacement. Without replacement. So the first card I'm going to draw is an R card. We know that the R card is a 2 over 10 or 1 over 5 probability. But now that I have gotten rid of one of my R cards, how many cards are left? There's only 9 cards left. How many of those are R cards? Only 1. Okay? Let me erase that for us. Okay? The next line says probability of an A card. Well, there's only one A card up here, so that would be 1 out of 10. But since I am not replacing it, I can get rid of that A card. What's the probability of an N card? How many cards are left? Only 9. How many of those are N's? 3. Well, 3 over 9 can simplify into 1 over 3. Okay? The next line says, how many N cards? Well, we just said that there were 3 N cards. Right now, it's our first card we're drawing, so there's 10 possibilities. Now I can get rid of one of those N cards. What's the probability of the second card also being an N card? Well, it's out of 9 because I got rid of one of those N cards, and there are only 2 N cards left. The next line says the probability of a D card. There's only one D card up there, so the probability is 1 out of 10. Now that I've gotten rid of the D card, what is the probability of an O card? Again, there's only one O, so that would be 1 out of how many cards are left? Well, there's 9. We're back to the R cards. Of being the first card, we know that it's 2 out of 10 or 1 out of 5. I can get rid of one of those R cards. So how many of those cards are M cards? Well, there's 2 M cards. How many cards are left? There's 9, so it would be 2 out of 9. All right. So that is how you work with replacement and without replacement. The rest of this note sheet is going to be talking about with replacement, or what we're going to call independent events. An independent event is 2 events or more that do not influence each other, or with replacement. Since we're replacing the first card, that will have no bearing on what my second card could be. In order to figure out the probability of 2 independent events both happening, so 2 independent events, that would be like having to do the dishes and it's snowing outside. Those have absolutely nothing to do with one another. So in order to figure out the probability of 2 independent events happening at the same time or back to back, it would be the probability of A happening, the first event happening, times the probability of the second event occurring. When we replaced the tiles in the above experiment, we were dealing with 2 independent events. All right, let's go ahead and move to the back side here. Here are more independent events. We are rolling 2 different colored die. Well, die or dice are going to have 6 sides. One of the dice or die are red, and one of the dice are black. Okay? So what is the probability that would roll a 3 on the red die? Well, there's only one side of a die that has a 3, so it would be 1 out of how many sides are there? 6. What is the probability that I would roll an even number on the black die? Well, how many sides are even numbers? 2, 4, and 6, so there's 3 even numbers on a dice, and there are 6 total sides, so that would be 1/2. So what is the probability that I would roll a 3 on the red die and a even on the black die? It would be 1 out of 6 times 1/2. Remember, when we multiply fractions, we multiply straight across, so 1 times 1 is 1. 6 times 2 is 12. My probability of both those events happening would be 1 out of 12. Let's go ahead and look at the next example. What is the probability that you will roll a 5 on the red dice? So we're still with the red and black dice here. A 5 on the red dice and a 1 or a 2 on the black dice. Well, first off, the 5 on the red dice. How many sides of a dice have a number 5 on it? 1 out of how many sides? 6. A 1 or a 2 on the black dice. How many sides of a dice have a number 1 or a number 2? That would be 2 sides out of 6. 2 over 6 can simplify into 1 over 3. So now we want to know the probability that both events will occur. How you need to write this is the probability of a 5 on red and a 1 or 2 on black. Yes, you need to write that in order to let me know what you're talking about. So the probability of a 5 on a red and a 1 or 2 on the black is 1 over 6 times 1 over 3. 1 times 1 is 1. 6 times 3 is 18. So the probability of both events occurring is 1 out of 18. Now we're going to go back to the tiles just like on the front. So we have all those letters there. What is the probability of choosing an A the first time and an E the second time? Note that you replace the A before choosing the second tile. So we are going to replace it. That means that it will be put back in. So the probability of an A by itself, is 1, 2, 3, 4. Out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it is 4 out of 15, and 4 out of 15 cannot be simplified. So that's okay there. What is the probability of an E on the second one? Well, I've put the A's back in, or the A that I pulled back in. So we just need to figure out the probability of an E in general. There's 1, 2, 3 E's. So that would be 3 out of 15, which can be reduced to 1 out of 5. So now what I need to know is the probability that I would pull an A and an E. How do we do that? Well, we multiply the two probabilities. So it would be 4 over 15 times 1 over 5. 4 times 1 is 4. 15 times 5 is 75. So that is the probability that I would pull an A, and then I would pull an E with replacement. Remember, that is always with replacement. I'm going to go ahead and get rid of our little notes here on the tiles, so we can move on to number 3. Using the same tiles, find the probability you will choose a U the first time and then an I after replacing. Remember, it's replacing the first tile. So a U the first time, it would be 1, 2. So that would be 2 over 15 is the probability of a U. The probability of an I after replacing the U would be 1, 2. It would also be 2 out of 15. So the probability that I would pull a U and an I would be 2 out of 15 times 2 out of 15. So that would get us 2 times 2 is 4. 15 times 15 is 225. The probability that I'd pull a U and an I is 4 out of 225. So let's think of 2 other events that would be independent of one another. Well, pulling cards out of a standard deck of cards, as long as we have replacement, and pulling marbles out of a bag of marbles, as long as we have replacement. All right. Well, that is the lesson for today. Just remember that an independent event is an event, or independent events are events that do not influence one another. Remember that in order to find the probability of two independent events occurring, we need to take the probability of the first independent event times the probability of the second independent event, and that would give us the probability of both occurring. And if you remember that with the probability with replacement, the number of overall events occurring does not change, but without replacement, where we're getting rid of a card, then the number of overall events will change. You will do just fine on this lesson. Remember, if you have any questions when you see me, please ask, and have a great day. Thank you very much.